Hi, welcome to section 2.1. We're going to talk about fundamental geometric ideas. So in this section, we're going to talk about properties of angles, parallel lines, and circles. So let's start with angles. Alright, so our first three properties. The first one is the total measure of adjacent angles around a point is 360 degrees. So adjacent means side by side. So here we've got some adjacent angles, and we've got three of them that go right around this point. So they're just going right around here. So if you think about it, A, B, and C, we're saying that angle A plus angle B plus angle C is equal to 360 degrees. Right? So the second one is the total measure of adjacent angles forming a straight line is 180 degrees. So here we have two angles that are forming 180 degrees. So this is angle A and angle B. And when you add them up, so angle A plus angle B is equal to 180 degrees. Okay, the third one that we're going to talk about is right angles. Put that right there. So we're saying the sum of adjacent angles is a right angle. So if we have two angles that come together at 90 degrees, so here's my 90 degrees, we can see that angle A plus angle B, because angle B is right here, adds up to 90 degrees. Alright, so those are adjacent angles. Now what we're going to do is we're going to talk about vertical angles, perpendicular angles, parallel lines, and a transversal. Vertical angles are basically two angles, or angles that are formed by two intersecting lines. So here I've got two intersecting lines. They intersect at a point. So we're saying that angle A is going to be vertical to angle B. They're also congruent. So angle A is congruent to angle B because those are vertical. Another set of vertical lines is C and D. So angle C is congruent to angle D because they are vertical angles. A perpendicular angle is simply an angle that forms 90 degrees. So here is a 90-degree angle. Parallel lines are two lines in the same plane that never intersect. So there's a set of parallel lines. Now a transversal is a line that goes through a set of parallel lines. So here's my parallel lines and here's my transversal. So my transversal is right there. Okay. Alright, now with this transversal comes a few properties, and that's what we're going to talk about in this one. Now whenever we have a set of parallel lines and a transversal, then we have some different types of angles that form. First of all, we're going to talk about corresponding angles. Corresponding angles are congruent angles formed by a set of parallel lines and a transversal that land in the same position. So let's label all of these angles A, B, C, D, E, F, G, and H. So now let's look at this for a second. And that box. I'm going to first look at angle A. I want to look for the angle that lands in the exact same position. So if I take and I cover up my top, I can see that angle E lands in that exact same position. It lands in the upper left side. So angle E is going to be corresponding to angle A. So angle A and angle E are corresponding. They're also congruent, so I'm going to write it like this. Angle A is congruent to angle E as my first set of corresponding angles. Now another set of corresponding angles, B and I want to look for the exact same position, and F. They're in the exact same spot, so angle B is going to be congruent to angle F. And then also angle C and angle G. So I'll put that up here. Angle C is congruent to angle G. And then D and H are corresponding. So angle D is congruent to angle H. Alright, now alternate interior. So what I'm going to do is I'm going to draw a box along my parallel lines, and I made it yellow. Now interior means inside, exterior means outside. Alternate means opposite of each other. So basically, if I look right here, angle D and angle E are opposite of each other, and if you look at their angles, they look the same. So alternate interior is inside my box. Angle E is congruent to angle D, and my other set is C and F. Angle C is congruent to angle F. Exterior means the outside. So now I've got angle A, and I want to go to the outside of my box. Opposite side is H. Angle A is congruent to angle H, and the other side is B and G. Angle B is congruent to angle G. So those are our types of angles formed by a transversal. So let's do a couple of examples. In the figure, find the measure of the angles B, C, and D. Justify how you know what the measure is. Okay, so first of all, I know that this angle is 40. So since C is a vertical angle, it's across from it, I know that the measure of angle C is also equal to 40, and the reason is because it's vertical to the 40 degrees. Okay, and now if I notice, I got a straight line here, so that means that angle C and D form 180 degrees. So the measure of angle D, because angle C is 40, we just found that, is equal to 180 minus 40 degrees, which is 140 degrees, because they are supplementary angles. And that means that they form 180 degrees. Well, so we said that this is 140 degrees. Well, we know that B is vertical to that, so the measure of angle B is also 140 degrees because it's vertical to angle D. Alright. Okay, we got another example with angles. And now we're have a transversal. So here we're starting at our 40 degrees. We could start this way. The measure of angle B is equal to 40 degrees because it's vertical. So here's my 40 degrees. We also know that the measure of angle E is going to be 40 degrees because it's corresponding to B. Measure of angle E equals 40, corresponding to angle B. Alright, so here's 40 degrees, and we know that angle G is also 40 degrees because it's vertical to E. So the measure of angle G equals 40 degrees as well because it's vertical to angle E. Okay, now the rest of it's going to follow suit. If I wanted to find angle H, we know that we have 180 degrees right here. So H plus G equals 140. So the measure of angle H is equal to 180 minus our 40 degrees. So we have 140 degrees. and that's because it's supplementary. So here we got 140 degrees. Angle F is also 140 degrees because of vertical angles. Angle D is 140 degrees because of corresponding angles. And angle C is 140 degrees because of vertical angles as well. Okay, I didn't finish out the writing, but if you have a problem like this, you're going to want to finish out your justification. Okay, those are vertical angles and parallel lines and transversals. Now we're going to talk about circles. Okay, so a circle is any point that is equal distance from a center. So if I have this circle right here and I make a whole bunch of points like this, and I draw my distance to any of those points, it's always going to be the same. So this is called the radius. Is the distance from the center to the edge of a circle. Okay, now we have diameter, and diameter is all the way across. We're connecting 2 points on a circle, and we're going through the center. So that's the diameter. So the diameter is going to be twice the size of the radius. Alright, so now what we're going to do is we're going to talk a little bit about lines and circles. So we said that a line and a circle can intersect in 0, 1, or 2 points. So first of all, if we are disjoint, they don't intersect. If we are tangent, they intersect in 1 point, and they could also intersect in 2 points. Same thing with circles. If we have 2 circles, they could be intersect in 0 points. They could be tangent. Tangent means 1 point. Or they could be intersect in 2 points. So, alright, so now we have an example. It says the following 3rd grade problem describes circles that intersect in 2 points, but the problem only has one solution. Why? Well, let's see. Gold is buried 4 centimeters from point B. So what I'm going to do is I'm going to take a ruler and I'm going to measure the distance from point B. I'm going to measure out 4 centimeters. So I'm going to take a compass and I am going to, or a protractor, I'm sorry. I'm going to take my protractor and I'm going to go out 4 centimeters and I'm going to draw a circle. There we go. Then it says we're 2 centimeters from point C. So I'm going to move this and I'm going to go 2 centimeters from point C. And draw my circle. Okay, I think that they are supposed to intersect. I think my picture might be slightly off. So we're just gonna, there we go. Alright, if we can see, our buried treasure is going to be right there. And the reason that we are only at 1 point is because they are tangent. Alright? So that is circles, lines, and angles. Thank you.